Alright, here we are at lesson 2, part of a whole as a percent. So to open this up in our math journal, one of the challenges that students will face when solving word problems involving percents is deciding which of the given quantities represents the whole unit and which represents the part of that whole unit. So again, going back to our discussion in Unit 1 about ratio, when we're comparing quantities, now we're specifically comparing parts to wholes. So as a percent, how does the value of a nickel coin compare to the value of a dollar? Well, a dollar is 100 cents, therefore the quantity 100 cents is 100% of the dollar. A nickel coin has a value of 5 cents, which is 5 out of 100 cents, or 5 over 100, which equals 5% of a dollar. So part of a whole percent problems involve the following: a comparison of generic numbers, for example 25% of 12 is 3, or a comparison of a quantity that is a part of another quantity. For example, the number of boys in a classroom is part of the whole or total number of students in the classroom. The number or quantity that another number or quantity is being compared to is called the whole. The number or quantity that is compared to the whole is called the part, because it is part or a piece of the whole quantity. So in our comparison of the value of a nickel coin to the value of a dollar, which quantity is considered the part and which is considered the whole? And explain your answer. Well, the value of a nickel coin is the part because it is being compared to the value of the whole dollar. The dollar represents the whole because the value of a nickel coin is being compared to the value of the dollar. Alright, so on your lesson worksheet, let's look at the opening exercise. For part A, what is the whole unit in each scenario? Continue the video to check your work. Alright, so you should be finished with part A. And this is what you should have. So 15 is what percent of 90? That means 90 is the whole unit. What number is 10% of 56? Well, 56 is the whole, and we want to know what is the part. 90% of a number is 180. Well, we don't know what that number is. We know that the part is 180 because it is 90% of it. But we don't know what the number is. A bag of candy contains 300 pieces and 25% of the pieces in the bag are red. So that means the whole is the 300 pieces of candy in the bag. 70% of the students earned a B on a test. So that means we're talking about all the students in the class. And also the same thing, the 20 girls in the class represent 55% of the students in the class. So we're talking about all the students in the class being the whole unit. Another thing you can look for in some of these problems is the word of. Typically the number that follows the word of is representing the whole number. So in this case, what percent of 90? Well then 90 follows the word of, so 90 is our whole. What number is 10% of 56? So 56 is the whole. And here, 90% of a number, well, then we don't know what that number is. Of, the number or value following the word of is not given, so that's why it is the unknown number. So how did you decide on the whole unit in each of the given scenarios? Well, in each case, we look for the number or quantity that another number or quantity was being compared to. Alright, go ahead and look at part B. Read each problem and complete the table to record what you know. Continue the video to check your work. Alright, you should be done with part B, and this is what you should have. So in each problem, 40% of the students on the field trip love the museum. If there are 20 students on the field trip, how many love the museum? Well, now you're given the whole. The whole is 20 students. The percent is 40%, and what we're looking for is the part. 40% of the students in the field trip love the museum. If 20 students love the museum, how many are on the field trip? So now we know that 20 is the part. It's still 40%, so now we want to know how many students total went on the trip. 20 students on the field trip love the museum. If there were 40 students on the trip, what percent loved the museum? So now we know that all of the students is represented by 40 and the part is represented by 20, so now we're looking for the percent. So how did you decide which number in each problem represents the whole and which represents the part? Alright, so example 1 on your lesson worksheet. Let's look at the question regarding Ty's math class. So is 30 the whole unit or part of the whole? Well, it is the whole unit. The number of students that earned an A on the test is the part and is compared to the total number of students in the class. So what percentage of Ty's class does the quantity 30 students represent? Well, it would be 100% of Ty's class. So solving the problem first using a tape diagram. So we're going to draw a tape diagram of this. And so if you need to stop the video to copy this down, please go ahead and do so. So we want a tape to represent a box or a rectangle, and that whole thing is 100%. And 100% is also 30 students. We want to know what 20% is, so approximately 20% is in this area. So 30 students make up 100% of the class. Let's divide the 100% into 100 slices of 1% and also divide the quantity of 30 students into 100 slices. What number of students does each 1% correspond to? So if we divide this into 100 pieces, we're also dividing 30 students into 100 pieces, which sounds a little sick, but that's not what we're talking about. So in this case, 30 divided by 100, so I guess 30 divided by 100 is 0.3. So 0.3 tenths of a student represents 1% of Ty's class. If this is 1% of Ty's class, then how do we find 20% of Ty's class? Well, we would take 1% and we multiply it by 20. So 1% times 20 is 20%. So we multiply 0.3 times 20, which gives us 6. So 6 students are 20% of Ty's class, therefore 6 students got an A on the test. So let's look at this problem using a double number line. So if we start with 0 and we draw some length of line and call it 100%, 20% would be somewhere in this area. If we draw that same number line, again 100% representing 30 students, then at that same point on the number line is going to be the number of students. So 30 students represent the whole class, so 30 aligns with 100%. There are 100 intervals of 1% on the percent number line. What number of students does each 1% correspond to? So again, if we cut this into 100 pieces, what part of students would represent 1%? Well, again, it would be 0.3, and 0.3 of a student represents 1% of Ty's class. So if this right here was 1%, then this would be 0.3 on the number line down below. So to help us keep track of quantities and the corresponding percents, we can use arrows to show the correspondences in our sequences of reasoning. So if 30 is the same or equal or equivalent to, and again, we're not using the equal sign, but if 30 corresponds to 100%, then 0.3 or 3/10 corresponds to 1%. And how do we do that? By using our properties of equality. If I divide 30 by 100, I divide 100% by 100. So if this is 1% of Ty's class, how do we find 20% of Ty's class? Well, the same thing. We multiply by 20. 3/10 times 20 is 6, so 6 students are 20% of Ty's class, and so 6 students got an A on the test. So to show that, if 3/10 corresponds with 1%, then multiplying using our properties of equality, if I multiply 3/10 by 20, I get 6, which means if I multiply 1% times 20, I get 20%. So 6 corresponds with 20%. So what similarities do you notice in each of these visual models? Well, in both models, 30 corresponds with 100%, so we divided 30 by 100 to get the number of students that corresponds with 1%, and then multiplied that by 20 to get the number of students that corresponds with 20%. Alright, so let's take a look at exercise 1. Use a visual method, that means tape diagram and double line graph, to solve the problem similar to example 1. Then continue the video to check your answers. Alright, you should be done with exercise 1. So, this is what you should have. If you draw a tape diagram, and they don't have to be next to each other, you can write this underneath, well then 100% would represent 25 projects, and somewhere over here you would indicate 12%. Well then on the same thing, if you have a double line graph, 0 to 100%, 12% being here, and underneath it 0 to 25 projects, and some number represents 12%. So, what we do is we take our 25 divided by 100, that gives us 25 hundredths, and then multiply it by 12. So 25 hundredths times 12 is 3, so therefore 12% of 25 is 3, so 3 art projects in Ty's class receive a perfect score. So now back to our math journal. What similarities do you recognize in example 1 and exercise 1? Well, in each case, the whole corresponded with 100%, and dividing the whole by 100 resulted in 1% of the whole. Then multiplying this number by the percent resulted in the part. So describe and show how the process seen in the visual models can be generalized into the numeric approach. Well, again, we divide the whole tape diagram by 100 to get 1%, and then we multiply by the percent that we need. And the whole corresponds to 100%. So in our examples, again, if 30 corresponds to 100%, we divide by 100 to get 30 over 100, which now is 1%. Then we multiply by 20 to get our 20%, and 20 times the part gives us 6. The same thing here. If 25 corresponds to 100%, divide by 100, so we get 25 over 100. 100% becomes 1%, and then multiply by 12. 12 times 25 divided by 100 is 3, and 12 times 1% is 12%. So 3 corresponds with 12%. Alright, let's take a look at example 2. So in Ty's English class, 70% of the students completed an essay by the due date. There are 30 students in Ty's English class. How many completed the essay by the due date? Well, first, identify the whole quantity in the problem. The number of students that completed the essay by the due date is being compared to the number of students in Ty's class. So the total number of students in the class is 30, and that is the whole. So the whole corresponds to 100%. That means 30 corresponds to 100%. And if we take 100% down to 1%, then that means we're going to divide 30 by 100. Then, because we want 70%, we multiply both sides by 70. So 70 times 1% is 70%, and 70 times 30 over 100, which would give us 2,100 over 100, reduces to 21. So 21 corresponds with 70%. So 70% of 30 is 21, so 21 of the students in Ty's English class completed their essays on time. Alright, so now into our math journal. is the expression 70 over 100 times 30 equivalent to 70 times 30 over 100 from the steps above? Why or why not? So think about that. We've transposed the 70 and the 30. Does that make a difference in our answer? Well, the expressions are equivalent by any order, any grouping property of multiplication that we talked about in our last unit. So what does 70 over 100 represent? What does 30 represent? And what does their product represent? Well, 70 over 100 is 70%. 30 represents the whole, and their product, 21, represents the part, or 70% of the students in Ty's English class. Notice that this is representing this. 70 over 100 is 70% of 30. Or we can say 70 times 30 over 100. So write a true multiplication sentence relating the part, the whole, and the percent in this problem. Well, that would be 21 is equal to 70 over 100 times 30. Remember, that's a change from our original problem because it was 70 times 30 over 100. But again, 70% is 70 over 100, and we can just multiply the percent by the whole. So translate your sentence into words. Is this sentence valid? Well, 21 is 70% of 30. Yes, the sentence is valid because 21 students represent 70% of the students in Ty's English class. So generalize the terms in your multiplication sentence by writing what each term represents. So now replace each one of those letters with something that each one of those values that represents or can be represented by a word. Well, it would look something like this. The part is equal to the percent times the whole. Now again, this is a little different than what we did at the beginning of the lesson, which we took the whole, divided it by 100, and then multiplied it by the percent. Well, now we can just take the percent, what is the percent, and multiply it by the whole. All right, example 3 on your lesson worksheet. So in percent problems, the percent equation, the part is equal to the percent times the whole, can be used to solve the problem when given 2 of its 3 terms. To solve a percent word problem, first identify the whole, quantity in the problem, and then identify the part and the percent. Use a letter or variable to represent the term whose value is unknown. So, on your lesson worksheet, a bag of candy contains 300 pieces, of which 28% are red. How many pieces are red? Well, which quantity represents the whole? Well, the total number of candies in the bag, 300, is the whole because the number of red candies is being compared to it. So which of the terms in the percent equation is unknown? Define a letter or variable to represent the unknown quantity. Well, we do not know the part, which is the number of red candies in the bag, so we're going to let R represent the number of red candies in the bag. So write an expression using the percent and the whole to represent the number of pieces of red candy. So again, going back to our equation. That means that it is 28 over 100 because again, we represent percent as a fraction. So 28% is 28 over 100. We're going to multiply that by the whole, which is 300. So now we can simplify it if you want as a decimal and write 0.28 times 300. So either way you do this is okay. But that's going to represent the amount of red candies since the number of red candies is 28% of the pieces or 300 pieces of candy in the bag. So write and solve an equation to find the unknown quantity. So we would do the part is equal to the percent times the whole. So R is our part, and that is going to be equal to 28 over 100 times 300, which is 28 times 3. And results in 84. So there are 84 red pieces of candy in the bag. All right, exercise 2. Complete the exercise and then continue the video to check your answers. All right, you should be done with exercise 2. If you followed the same pattern as example, or as the previous example, then this is what you would write. The bag of candy contains 300 pieces in which 28% are red. So now we've changed it. How many pieces are not red? Well, write an equation to represent the number of pieces that are not red. So now we're going to subtract. If we knew 100% and 28 are red, then that is going to be 100 minus 28, which would be 72. And we would multiply that by 300. So now use your equation to find the number of pieces of candy that are not red. Again, don't forget, we're not using 28, we're using the difference between 100 and 28. So that is our original equation, and then we simplify it. Well, 100 minus 28 is 72. If you started with 72%, the question is going to be, how did you get 72%? So that's why this first equation is really important, to show that you are going to get 72%. And then the following is the same as what we did before. 72 over 100 times 300, which is 72 times 3, which is 216. So there are 216 pieces of candy in the bag that are not red. Now, if you did the equation by just subtracting from the answer from the previous question, then that is not going to satisfy any of the questions here. So Jali told his math teacher he could use the answer from part B and mental math to find the number of pieces that are not red. Explain what he meant by that. Well, once you know that there are 84 pieces of red candy, then 300, you could subtract 84 from 300 to get 216. So that just kind of summarizes what I said before. You can do this mental math without using the part equals percent times whole equation, but that's the reason why they included part A and B. All right, so we saw in Module 3 that it is possible to find a solution to a formula or algebraic equation by using the properties of operations and if-then moves to rewrite the expressions in an equation in a form in which a solution can be easily seen. So examples 4 and 5 that we're going to do use the algebraic formula, part equals percent times whole, to solve percent word problems where they are given two of the following three terms: the part, the percent, and the whole. So now we can interchange which parts were given and which parts are missing. So let's take a look at example 4. Zoe inflated 24 balloons for decorations at the middle school dance. Is Zoe inflated 15% of the balloons that are inflated for the dance? How many balloons are there total? Solve the problem using the percent formula and verify your answer using a visual model. All right, so again, what is the whole quantity? You have to identify that whole, and how do you know? Well, the total number of balloons at the dance is the whole quantity because the number of balloons that Zoe inflated is compared to the total number of balloons for the dance. So what does the 24 balloons represent? Well, the 24 balloons are part of the total number of balloons for the dance. Write the percent formula and determine which term is unknown. Well, if we use part equals percent times whole, the part of the balloons is, or the part is 24 balloons and the percent is 15. So we're going to let T represent the unknown total of the balloons. So that means we're going to have 24 is equal to, and again we write the percent as a fraction or decimal. In this case they're doing a fraction, 15 over 100 times T. Well, if A equals B, then A times C equals B times C. So we're going to multiply both sides by the reciprocal, because again we want to get T by itself. So what number is going to allow us to get 1T? Well, that is multiplying by the reciprocal. So the multiplicative inverse of 15 over 100 is 100 over 15. And again, using our properties of equality, if we do that to one expression, then we need to do it to the other expression. So now we have 2400 over 15 equals 1t, and that is using the multiplicative identity property of 1 and equivalent fractions. Okay, so these are equivalent fractions. 1t is equal to 2400 over 15. And when we reduce that or simplify it, we get 160. So the total number of balloons to be inflated for the dance was 160 balloons. Which means that 15% is equal to 24. So here's another way we can do this. If 15% corresponds with 24 balloons, then 1% dividing by 15, which if you notice up here we're dividing by 15, is equal to doing 24 divided by 15, which if you simplify this you can kind of see that this is 24 divided by 15. Well, we want that quantity to correspond with 100%, so we find 1%. So now we want to know what is 100%. So what are we going to do? We're going to multiply this by 100. So if we multiply it by 100, we would get 24 over 15 times 100, and notice what we'd get here. 24 times 100 would be 2400. So 24, and they just went ahead and reduced this already. 24 over 3 times 20 is 160. So 100% is 2400 over 15, or 24 thirds times 20, which is 160. All right, so our visual model, again, we didn't know that it was 160, but we knew that this was some number. So 15% is going to be 24 balloons, and 100% is going to be some number which ended up being 160. So if we do a double number line, we have 0 to 100%, we want 15, or we know 15%. Well, if again we split it up into 1%, and I'm not saying that this is the length of 1, but obviously if we take 100% and find 1%, then that's going to correspond, 15% is 24, which means that we want that same value. What is 1% of 24? Well, that would be 24 over 15, because we want to divide it by 15. Well, then that means to get 160, we would multiply this 100 times. So if we multiply 100 times 24 over 15, we would get 160. So is the solution from the equation consistent with the visual and numeric solution? Well, you should say yes. All right, example 5. Haley is making admission tickets to the middle school dance. So far she's made 112 tickets, and her plan is to make 320 tickets. What percent of the admission tickets has Haley produced so far? Again, solve the problem using the percent formula and verify your answer using a visual model. Well, what do you know is the whole quantity, and how do you know it? So the total number of admission tickets is 320, and that is the whole quantity because the number of tickets that Haley has already made is compared to the total number of tickets that she needs to make. So what does the quantity 112 tickets represent? Well, 112 tickets is part of the total number of tickets for the dance. So write the percent formula and determine which term is unknown. So we have part is equal to percent times whole. And the part is 112 tickets and the whole is 320 tickets, and we'll let P represent the unknown percent. So therefore 112 is equal to P times 320. And again, if A is equal to B, then A times some number is equal to B times that same number. So since we want to get P by itself, we're going to multiply by the reciprocal, or the inverse, of 320, which is 1 over 320. But again, if we do that, we have to do the same thing on the other side. So now we end up with 112 divided by 320, or 112 over 320, and that is going to be equal to 1p. And again, the multiplicative identity property of 1 means that we have p by itself. So reducing that, we would get 7/20 equals p. The only problem with that is 7/20ths is not a percent because our denominator is not 100. So now we need to make an equivalent fraction. Or in this case, we can come up with a decimal. So 7/20 is the same as 35/100ths. Well, 35/100ths is 35/100, which is 35%. So Haley has made 35% of the tickets for the dance. You could just take 7/20ths, multiply each top and bottom by 5 to get to this part right here, and skip the decimal, but in either case you should end up with 35%. So on a number line, this would be 0 to 100. We know that 112 is the part and 320 is the whole. So what percent is 112? So we know that the percent corresponds with 112, so first we find the percent that corresponds with one ticket. So we could do it using our 1%, or one ticket in this case. Well, if 320 is 100%, then 1 is going to be 100 divided by 320. Well, then we need 112 tickets, so now just multiply 112 times 100 over 320%, and you would get 112 is equal, they're simplifying it here, but then you would get 7 times 5, which is 35%. So either way you do this, you can either bring it down to one ticket or 1%, but you're still doing a combination of dividing and multiplying, or multiplying and dividing. So is the solution from the equation consistent with the visual and numeric solution? Well, your answer should be yes. All right, so to wrap this up, what formula can we use to relate the part, the whole, and the percent of the whole? Translate the formula into words. Well, you should have part is equal to percent times whole. The part is some percent of the whole. What are the advantages of using an algebraic representation to solve percent problems? Well, if you can identify the whole, part, and percent, then the algebraic approach is very fast and very efficient. Explain how to use a visual model and an equation to determine how many calories are in a candy bar if 75% of its 200 calories is from sugar. Well, you would explain that using a double number line or a tape diagram. The whole, which is the total calories, corresponds with 100%. So 200 calories divided into 100 intervals shows that every 1% will be 2 calories. That means there's 150 calories from sugar in a candy bar. All right, we'll see you in class.